So following from the last video, this time we're going to take the integral of tangents to the third power as well as the integral of cotangents to the third power, of course with respect to the variable that we're dealing with. So how do we do it? Here we go. So actually we're going to stick on the trigonometric identities, or you can think it as a Pythagorean identities that we actually need to play around. And this time we cannot use sine and cosine anymore, but we're going to change it to tangent and secant for this case. So to do that, we're still going to break tangents to the third power into tangents of x times tangents square of x dx. Then we're going to rewrite tangents square of x into the following. So from the identity, it says that secant square is actually equal to 1 plus tangent square. So we can subtract 1 on both sides to get that tangent square is in fact equal to secant square minus 1. Good. So now we're going to again distribute the tangents into the two terms to in fact get tangents of x times secant square of x dx for the first integral minus just tangent of x dx for a second integral. And for the first integral, what are we supposed to do? Well, let's try to do a use up again, but what should we choose this time? Well, we actually have tangents here and we also have secant here, but we have two copies of secant. And in fact, it is also something that you all should memorize. The derivative of tangents of x is in fact equal to secant square of x. So if we do a use up, we should actually try to use tangents of x here, such that when we take the derivative of u or du, we will actually get the second part, secant square of x dx. So in that case, we will just have integral of u du. And if we take the integral of that, we'll have 1/2 of u squared. But what is u again? U is tangent. So we actually get 1/2 tangent square of x. That's it for the first integral. Now for the second integral, if you don't remember, you can go back to one of my old videos and find out the results. But in fact, we would need to rewrite tangent as sine over cosine and then do a use of where u will be the denominator cosine. And then, of course, in that case, the du part will just become the numerator sine of x with a negative sign, meaning that we actually will distribute the negative into it, such that we will actually get the integral 1 over u du. And what is the integral of 1 over u? Well, of course, it's just ln of the absolute value of u. But in this case, what is our u again? It's the denominator, cosine of x. And therefore, we are almost done. Don't forget, we still need the plus c, the constant part. All right, now we finished the tangent cube part. Let's take a look to the other problem. How to take the integral of cotangents to the third power, or cotangents cube of x with respect to x itself, or dx. So, of course, we're going to play the same game by breaking the third power into cotangents x times cotangents square of x dx. Next, we're going to use the identity again. Now this time we have cotangent square. So which one do we use? We're going to match it with cosecant square. And the formula says that cosecant square is equal to 1 plus cotangent square. So we need to subtract 1 on both sides. So cotangent square is in fact equal to cosecant square minus 1. And don't forget the dx here. So again, we now will just distribute the cotangent x into every single term inside of parentheses. And we're going to break it into two different integrals. So we get the following. And then for the first integral, we're going to do a u sub again. What should we let this time? Of course, we should let u be cotangent of x, such that if we take the derivative, du will be equal to negative of cosecant square of x dx. But we don't have a negative sign. What do we need to do? Well, we can just try to put a negative sign in the front and then also multiply another negative inside of the integral so that we're not changing the value, such that now we will just get negative of the integral of u du here. And if we take the integral of it, we'll of course get negative of 1/2 of u squared. And what's our u again? It will be cotangent. So we will have negative 1/2 of cotangent square of x for the first integral. And then for the second integral, we're going to rewrite it as fraction again. So we will actually get cosine over sine. And once again, when we do u sub of such kind of function, we would like to set the u be the denominator sign here. And then if we do that, du will be the top part, just cosine of dx. Cosine x times dx without the negative sign. So we can actually keep the negative sign in this case, and we will turn the integral into 1 over u times du. So if we take the integral of that, we'll get ln of the absolute value of u, and again this time the u will be the denominator, sine of x. And last but not least, we need to put the plus c. And that is it. Alright, so for the next video, we're going to find out the most difficult two expressions, which will be the integral of secant to the third power of x dx, as well as the integral of cosecant to the third power of x dx. And this will be the last video for the for this kind of problems. For the fourth power above, I'll just let you guys to work it on as an exercise. Okay, so that's it. I'll see you guys in the next video.